Hello everyone, we have a question from weekly contest 502, largest local values in a matrix 2. We have given a matrix n cross m and a non-zero cell row, comma column checks the cell, x is the value of that cell, and we have to consider within x rows and x columns of that cell. Okay, ignore the cells that are outside. Okay, ignore the cells where both the row distance and column distance are exactly x. We will cover these parts. Okay, and you can read the whole question here. We have to find return number of local maximum in matrix. Example here, and constraints can go to 200 only, and matrix values can also go up to 0 to 200. This is very important part. Okay, so let's understand the question first. So suppose we have matrix. Let me show you here. Okay, we have the same matrix here. Okay, suppose kya, we have only one non-zero cell, which is 2. Okay, then which is at coordinate 3 comma 3. Okay, you can check this as 3 comma 3. Okay, so we have to choose only within this range up to x, means 3 minus 2 columns, 3 minus 2 rows to 3 plus 2 rows, means 1 to 5 rows. See, 1 to 5 rows we have taken. Okay, same goes for columns, as the 3 and 3 are same, row and column are same, so column will also vary from 1 to 5. Okay, now we have to discard or ignore the corners, as have been said here. Not corners, let me tell you. Okay, ignore the cells where both the row distance and column distance are exactly x, means from 3, let's suppose we have coordinate x equal to 2, means row distance is exactly equal to x, which is 2. Let's don't confuse this x with this. Okay, this is other x, so we can open the mod. Okay, we will get two values of x, 1 and 5, and this for same distance y, this will also be same, because here 3 comma 3 is same. Okay, so now we have to create different combination of x and y, so we can check. We are getting this 1 5, sorry, 1 1 1 5 5 1 5 5. Okay, 1 1 1 5 5 1 5 5. Okay, now we have to discard, means we have to discard like 1 1 1 5. Okay, this and this, which I have shown here. Okay, now let's proceed further. This is a long question, so we have to go step by step. So let's check brute force approach, which everyone can think of. I can say we have taken an nm length of matrix, x is the value. Okay, let's read from here. Counter variable, which is store the count of local maximum in a matrix. Okay, we are going from every row to column. We are extracting the value of x, and if it's 0, then skip, because we are only around non-zero values. Okay, let's set a flag boolean of true, which will help us to actually count or break out from the outer loop. Okay, so we are going from I equal to r minus x, this line meaning both distance are exactly x. Okay, this is that thing, because suppose we have a center, so we can go same amount of distance up and down, up and down. Okay, so we have written r minus x, it's like r minus x. Okay, and r plus x, this will cover row, and r minus column, r plus column will cover the all column range, you can say. So we have done here same thing. Okay, and if it is going out of boundary, as said here, ignore the cells that are outside the matrix, we will skip. Then we are checking. Okay, same thing, if distance is same, then skip. And if we get another value of cell which is greater than the x which is previously, okay, then suddenly set flag as false and break out the loop. Okay, then if we don't get and it is remains true, means we didn't get any other value which is greater than previous x. Okay, then we our do count plus plus and return count. Time complexity is very high. Okay, 200 into 200 into 200. This for matrix traversal and this for checking every row and column. Okay, into 200. We should go up to 199, 1.619. Surely it will get really because 1 second equal to 1 unit operation at max in LeetCode or core forces both platform. Okay, let's erase all this. Now what we have to optimize here is how we can reduce the number of operation here applied. Like for every row, every column, we have to check again and again that greater than equal to x thing. Okay, so what we will do in this type of question, always think of pre-computation, which is prefix sum. Okay, there can be various conditions like greater than x, less than x. Okay, or both came together. So we have to mark, remember we have to mark some values in matrix, either 0 1, so that we can differentiate like 0 for normal cases, and if we say mark 1, then it will be for greater than cases. Okay, so what we will do, I will let me show you. Let's say this is a matrix where, yeah, we have our matrix. Okay, given, for example, this matrix we have initially given input matrix. Now we will create our own matrix. Okay, and we will mark those indices values with 1 whose value is greater than that x, or you can say threshold. Okay, so 1 is not greater than 3, so 0, it will greater than, it is greater than 3, so 1. Like this, it is not 0, it is 1, it is not strictly greater than 3, so it will stay also 0. This is 0, this is also 0, this is 1 and 1. So okay, we have calculated, so we have made prefix sum, then prefix array, then we have to think of prefix sum which will tell something. Okay, so right now p of I comma j, number of ones from 0 to I comma j will tell. Okay, meaning of p of I comma j. Okay, now we have to take prefix sum of this, which will tell count of how many numbers which are greater than equal to that x. Okay, so it is also very important to know how to calculate 2D, how to calculate prefix sum for 2D matrices. Okay, this is separate concept for this. Okay, you can't just add and add, because it will at some point it will overlap. Okay, suppose you have to calculate this and also this. Okay, so this will be overlapping. Okay, so let me tell you how will you calculate. Let's erase all this. So for calculating prefix sum of 2D matrix, you can say these will be same, like these will be follow simple 1D array running sum. Sorry, here you can check 0 0, 0 plus 1 1, 1 plus 0 1. Okay, and this will also force vertical case 0 here, 0 plus 1 1, 1 plus 1 1, sorry, 1 plus 0 1. Okay, to fill out this position. Okay, let me zoom. So how we can fill, we will fill, we will go up here and left. Okay, you can say up and left. Okay, and take common of this. So how we calculate, we will go left. Okay, we will have left thing and up thing. Okay, 1 plus 1 2, the common part is this I minus 1 j minus 1. Okay, this is I minus 1 j minus 1, This is I minus 1 and this is j minus 1 comma j. Then check 1 plus 1 2 plus 0 2 to 2. Okay, same goes for this value 0 plus 0 0 plus 0 0 plus 1 only 1 we get. Okay, let's check for this. I will calculate 1, or you can check simply formula. Okay, left plus right minus the common part which will overlap plus that cell value. Okay, I hope you know this. Okay, also check. Suppose we have 3, we will go left 2 plus 1 3 plus minus this part 2 plus 3 minus 1 2 plus 1 this part. Okay, matrix which will come 3. I think this is okay. Okay, this will tell how many numbers, how many cells having greater than x. Some will tell. Okay, at that point you will use as a query. Okay, this is the thing which was taking time for every operation, like n cross n. Okay, now using prefix sum we can calculate in O of 1 time, because we know now sum between, so we can fetch the sum using matrix. Okay, so let's proceed further. Okay, let's do one more thing. Let me tell you, as I said earlier, matrix values are also going, it is like given for 0 to 200. Okay, those are open, you can check. Okay, so we have to make for every value matrix. Okay, can't conclude in one matrix because it will be so much lengthy and there are many state changes. You can say we have like one for 0 to 200 matrix, and this is for one column. Okay, it will be like this. Okay, 200 matrices will be there. Okay, which is threshold. You have to check now which value it is greater than or equal. Greater than is strictly greater than, not equal. That is the condition of our question. So let's build this matrix first. Let me show you code. Same thing I have written here in words. Okay, so length n1 we have made a matrix. I think we have got this 201 part. Okay, because say we have only 3, threshold as 3, so say one matrix will be there for 4, another matrix so on, and there will be 200 matrix. Now let's traverse and make a temporary matrix. Okay, then traverse rows and columns. This is the marking step. If matrix value is greater than that value which we are creating the matrix, then mark as a 1. Okay, then here comes the prefix sum, taking the prefix sum of 2D. Let me write prefix sum. So we are going every row and column. Okay, and this is we are fetching, we have to fill temporary, and this you can also calculate that thing. Okay, let me tell you once again, like take the normal 1D sum of this thing, row wise, same goes for column wise, like normal array. Okay, normal array में क्या होता है, जैसे prefix sum of I comma j plus equal to that cell value. Okay, I hope everyone knows this. Same thing you can do, and then you can subtract a common part. Okay, which I am doing in code. Let me show you. So I is positive, take only normal prefix sum. Okay, this, if both is positive, then this is common case. Okay, then subtract this thing. Okay, so we are done with this part. Then we have answer variable which will store the number of local maximum count. Okay, again going to matrix, this is mandatory, like very basic thing. Extracting the value of cell in that cell. If it is 0, then skip because we need only non-zero. Now this is the range, okay, that limit thing, within thing, okay. So R1 will be max of 0 comma R minus X. Everyone can understand it, I think. Okay, now we have count variable and we have query. Query, what is query? Okay, let me tell you. It will count number of, it calculates sum of element inside a rectangle, like from R1 C1 to R2 C2. P of I comma j क्या था? Sum of rectangle from 0 0 to I comma j. So this is same thing we are calculating. Okay, suppose we need to find only particular value, like I002, we have only 1 comma 3, so you have to find it in O1 O of 1 time. Okay, that's why we have made. So let's check what we are doing. Answer variable prefix. Okay, so we have passes the prefix array and coordinates basically. So now we can till that point final sum. Now we can subtract to get desired sum. Okay, let me show you. Count, same thing we calculated, like final value will be like ultimate value of whole sum. Okay, let me clear this thing. Suppose I comma j, not I comma j, take R1 C1. Okay, so that end point will be store the whole sum. Okay, suppose from R1 C1 to R2 C2, and let's fetch the final value, final sum. Okay, then we can subtract from final sum to get our desired sum. We'll subtract these rows and columns to get our particular sub-rectangle sum, you can say. Okay, so that is the thing we are doing here. Same, we have ultimate sum, then if row, then subtract that, column stays same, and if column, subtract that column, row stays same. If both are means overlapping case, then add. In prefix sum we are subtracting, here we have to add because we are doing reverse thing. Okay, then return the answer. Now we didn't have eliminated corners yet. Okay, means this thing, equal distance thing was corner cases. Okay, you have to remove the corner elements like here. Okay, now we have to also subtract this. Okay, so that effective condition will fulfill. Now we have stored corners at R minus X. You know how this came. Okay, this part. Okay, check this. I is the coordinate, R is the that cell value ij, next is the ij comma x, a of ij, okay, then we have, let me erase here. So R minus X, you can break the mod into two parts. Okay, R minus X, R plus X. Same goes for column, so we will get 4 combination like this. Okay, it is generalized, you can say. So now we have to traverse through the corners, fetch ij. If it is in the matrix not out of the boundary, then also we have to do count minus minus only when it is greater, otherwise it will make no effect. Okay, so we did counter minus minus, and after all this, if our count becomes 0, then we have got our local maximum, because there is no other cell where local maximum is another cell. Okay, so we increases our count, answer plus plus, and finally return the answer. Okay, time complexity is final code of this will be 201 200 into 200 prox 246, like, or 247, you can say 1 is 7 something. TC. Okay, space complexity will be same impression because we are making prefix array. Okay, so this was the question. It includes many things like prefix sum of 2D array and query problem, how to handle optimize this in O of one time. Okay, this was good question, although I was also not able to solve in contest. I did only brute force, you can check. Okay, and people also saying this is good. Acceptance rate is also very low. Yesterday it was something around 11%, if I remember correct. Okay, so this was the problem. I know I have not explained in that much, but I am trying. Okay, let's see the check the code at once again. Whole code: creation of matrix, calculating prefix sum, assigning answer, then defining boundaries of within thing, then query to fetch the subrectangles in O of one time. This is the optimization. Okay, then subtracting corner. Okay, so that given condition get fulfilled. And if it count, because count is the number of cells which are greater than that cell value x. If 0, then there is no, and that is local maximum. So do answer plus plus, then return answer. Okay, this is the query part. Reverse engineering, you can say, where we have ultimate sum at r2 comma c2, then we subtract to get our desired, okay, sum. So let's end this. Thank you.